Okay, so let's get started. We're going to be taking a look at setting up and working with an open loop boost control strategy found within our Link G5 and G4X system programming. Now, our open loop style boost control is the most simplistic way to control boost with a boost solenoid using your Link for programming. Now, I always recommend to run closed loop style boost control, but sometimes you want to keep things simple and really basic. Especially if you're getting started with tuning, this isn't a bad strategy just to get a handle on understanding the relationship between the duty cycle you're commanding to the boost control solenoid and increasing the boost pressure. So what we're going to do here in this training module is just cover some of the basic details, making sure that you have your vacuum routing correct on the boost control solenoid to the wastegate for control for both an internal and an external wastegate, go over some of the basic settings and details that we have to make sure are configured correctly. Then we're going to walk through just the general approach to tuning and working with a 3-port style boost control solenoid. Now, you can work with 4-port boost control solenoids, but they tend to be extremely coarse in adjustment, meaning a very small amount of duty cycle equates to a very large amount of boost change. It's problematic and very difficult to get boost consistent with a 4-port solenoid. I always recommend to run a 3-port solenoid that'll give you majority of what you need to control for boost. If you need to get more boost than what a 3-port solenoid can provide, you can always pair up and do dual 3-port solenoids for top and bottom port control. We're going to have a separate tutorial talking about that topic a little bit later here in the training course. But for right now, let's start to talk about some of our configuration settings and details to make sure our boost control solenoid is wired correctly, as well as routed correctly in the vacuum line routing to the wastegate, pressure source, and the boost control solenoid. So the very first example we're going to take a look at here is going to be for a 3-port solenoid controlling an external wastegate, so a single external wastegate. And we'll find here, we're taking a look at the actual boost control solenoid, there's going to be numbers on the solenoid to the ports. Port 1, port 2, and port 3. Port 1 is going to go to the pressure source coming typically from your compressor cover or charge pipe. It can come from the intake manifold, although sometimes this is problematic because a vacuum source from the intake manifold will pull a vacuum in the diaphragm assembly of the wastegate. And what can happen is the actual diaphragm can start to pull into the wastegate fitting and rub and actually wear a hole in it. And over time, that'll create a ton of problems for boost control. So I always recommend trying to run a pressure source only into both the bottom port of the wastegate, as we can see here in our picture, and then the port number 1 on the boost control solenoid. So those both will split and share the same pressure source. Now we have our port 3, that's going to be vent to atmosphere. We're going to make sure that's not going to be blocked. You can put a small bronze filter on that particular port so no dirt gets in the solenoid, but that does need to vent to atmosphere freely. Then port 2 is going to simply be routed to the top port on the wastegate. When the boost control solenoid is not energized, it's in its off state, this is normally closed in this routing, meaning no pressure will go through the boost control solenoid to the top port of the wastegate. Once we start to energize it, commanding duty cycle to the solenoid between 0 to 100%, as that duty cycle picks up, the solenoid will allow more and more boost pressure to bypass through the solenoid, so going from port 1 to port 2 and pushing into the top port on the wastegate. So that'll allow us to have a higher mechanical push on the wastegate valve and act like a stiffer spring that's in the wastegate. So looking at this routing here is pretty basic. This is what you need to adhere to for an external style wastegate with a 3-port boost control solenoid. The other thing I want to talk about here is going to be the wiring for the boost control solenoid. There's 2 wires. One wire is going to go to a Keon 12-volt power source. The other wire is going to go back to the link, and we're going to be low side pulsing it in a pulse width modulated output to control the solenoid. So it's a pretty simple circuit, but we need to make sure that wiring is done in that exact manner. Now, there's no polarity on the solenoid, so either wire can be ran to power and the other wire can run to the control side from the link pulsed in that low side fashion. Okay, so now that we've talked about pretty extensively here our external wastegate, let's go to our next example here and take a look at an internal wastegate. Now, in this particular configuration, we're going to find we have our pressure source coming from our charge pipe or our compressor cover, and that's going to run into port 3 on the 3-port boost solenoid. Then port 2 is going to go to the nipple on the actuator, the wastegate. And what we'll find in this configuration is that when we have the boost going into port 3 and then it's routed to port 2, that will be in a normally open state. So when it's not energized, it's going to act like that boost control solenoid's not there, and the pressure is going to go from, again, the compressor cover to the nipple on the internal wastegate. In this configuration, we'll have whatever that wastegate spring pressure is going to be as a base, and then as we start to energize the boost control solenoid, it'll start to bleed the pressure from our compressor source, our pressure source, through port 3 out of port 1. So the higher the duty cycle, the more we're venting from port 1, and then the less we're putting to port 2 to the internal wastegate nipple on the actuator. That's going to essentially turn up the boost pressure. So an internal wastegate works a little bit different, kind of the backwards way from an external wastegate. So hopefully that's clear how we are going to set this up. And again, the wiring is the same, 12 volt power on one wire. Other wire is going to be controlled through an aux output, low side pulse width modulated. The last example here I just want to show, if you have a exhaust manifold that has dual wastegates, we can use a 3-port solenoid, so we don't need twin solenoids. And what we'll do here is we have our pressure source that's going to be ran into port 1, and then we're going to tee out of that, and we're also going to tee the same pressure source into the lower ports on our wastegate. Then port 2 is going to go and be teed to both top ports on the wastegate. Port 3 is going to be vent to atmosphere. Again, this is going to be a normally closed state with the routings from port 1 to port 2. And as we energize with duty cycle to the boost control solenoid from the link, going from 0 to 100% duty cycle, that will start to energize the solenoid. It'll start to pass pressure from port 1 to port 2 and put more pressure on the top port of the wastegate and act like we're running a higher spring pressure. So the control and setup here is essentially the same. It's just the routing is a little bit different. Make sure that that is correct for a dual wastegate setup. Now, as we're on the topic here, just quickly of dual wastegates and on external wastegates, whether it's in a single wastegate or a dual wastegate, you have to make sure that your spring pressure is adequate so that you have reasonable control over your boost pressure. So what does that mean? Whatever the spring pressure is at within our external wastegate, or even the internal, that's going to be the same thing with the internal actuator. It's going to have some rated spring pressure, some rated boost pressure that it's going to work at. That's going to be the minimum amount of boost that we can run. So on an internal or external wastegate, if we have a 10-pound spring or a 10-pound actuator for the internal wastegate, we can't turn the boost down past that point. We can turn it up past that point. And the general rule of thumb is whatever an internal wastegate actuator is rated at, let's say that's 10, we can usually double it with a boost control solenoid. When we're talking about an external wastegate, we can usually go 3 to 4 times, sometimes even higher, than whatever the spring pressure is at in the external wastegate or wastegates. If we have dual wastegates, it doesn't really matter. So if we have a 6-pound wastegate spring, a lot of times we can hit anywhere between 20 to 30 pounds of boost with that low wastegate spring. The reason why you should consider what your wastegate spring is going to be before you do any actual tuning and getting everything configured and set up mechanically is that you want to be able to regulate the amount of power and the amount of boost that you're going to be running through the engine so that, let's say you have a front wheel drive car that's going to be traction limited. You're able to, in let's say first gear, where it's going to have the hardest time putting down power and torque, you can lower the boost down, lower the power and torque down, and be able to bring the power in very specifically. So as you want to have more power going into the higher gears and as engine RPM picks up, you're able to ramp in the boost control solenoid, to ramp in the boost, to ramp in the power and torque output out of the engine. So you can use the boost control solenoid to manipulate your boost and your power range, but you can only do that if the wastegate spring is going to be reasonable and low to begin with. So if I install a 15-pound wastegate spring and I expect to be able to run lower boost in first gear, that is not going to be possible. You have to consider that wastegate spring, whether it's going to be the external wastegate or whatever the wastegate actuator is rated at on an internal. So again, to reiterate this, run as low of a spring pressure so it's going to give you a decent range of boost adjustment. You don't, on an internal wastegate, you can usually can double the rated actuator. So if it's 10-pound actuator, you can usually get 18, 20 pounds out of it with no problems. With an external wastegate, we can usually go 3 to 4 times the rated spring pressure. Sometimes I've been able to get as much as 5 to 6 times the rated pressure. That really depends on what the exhaust back pressure is going to be in the actual exhaust manifold. So how high of an exhaust back pressure we get really dictates what we can get out of the spring. So hopefully all that makes sense. Okay. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.